That it, how are the services spread across the world, and how do we use the services, right? Um, we are not going to get into too much detail of creating services and working with services. That maybe we can cover in some other session. But right now, it's going to get you just started with Azure. Okay. So before starting with Azure, let's start with cloud, right? So what is cloud? What is it? So cloud is nothing but uh, a way of getting infrastructure without owning it, right? So traditionally, what happens is, if a company requires some compute infrastructure, maybe storage, maybe virtual machines or databases, they purchase their own big computers, big servers, right? Maybe hundreds of them, and then configure those servers to solve those problems, right? Maybe create virtual machines or set up databases on them, or set up some corporate applications on them, right? So that is a traditional way of getting the compute. Well, this has a lot of challenges, right? This is a traditional way of owning everything. So the company or the organization owns the owns owns it completely, owns everything, starting from power and the building in which the servers are kept, up to the operating system and the applications on the servers, right? So everything is owned by the organization. This is not very scalable, right? What if we need 5 virtual machines for 10 days only because we are trying out something? Do we need to buy a new server for those virtual machines? Or what if we are expecting a high customer high amount of customer requests for our web application momentarily, right? Maybe we are launching a new product and we expect a lot of potential customers to come look at our website and look at the product. Then we need to scale our systems, right? How can we scale it when we don't have the elasticity of adding new infrastructure, because we are limited by what we have here, right? So for those cases, cloud comes into picture. Cloud is a way to get compute resources without actually owning the physical infrastructure, right? So we have AWS, which was I think, the pioneer of cloud service provider. Then now we have Azure, we have Google. We also have others like, Oracle Cloud Infrastructure. We have Ali Cloud and many others. But these three are the main players, right? And we are going to take a look at Azure today, how Azure works. Okay, so let's move it a bit. Give me a second. Right. So before moving on to Azure, let's understand what is a shared responsibility model. Responsibility model. This is very important to understand, right? When you are when you use any infrastructure, right, you have certain set of responsibilities towards that infrastructure. Okay. For example, let's quickly open something up. Just give me a second. Just give me a sec. Try to open my browser. Yeah, right. So let's say Let me copy a diagram from somewhere. Yeah, copy it, and I'll just paste it here. Okay, so this is a very good example of shared responsibility model, right? Let's say you have an on-site data center, right? You have set up your own servers, and your company manages those servers, and your company also utilizes those servers for writing programs or whatnot, right? In that case, you end up managing everything of your infrastructure, right? The blue ones are the servers or are the components of your infrastructure that you have to manage. It starts from the bare metal or bare uh, systems networking, right? How do you set up networking? How do you set up storage? Then how do you set up servers? How do you virtualize them? How do you run your operating system, right? Then on top of operating system, then the developers come in. So, install some middleware, install some runtime, then your data and the application. Generally, in a traditional company, up to operating system, the responsibility is with the IT team, right? IT team sets up everything and gives the developers or and users the systems. And the developers then maintain this part, middleware, runtime, and all. Imagine you are developing an application in Java. So you get a virtual machine with Linux, and then you install, JDK on it to run some application. You install maybe Tomcat on it. Then you run your web application and data, right? So this is kind of responsibility. Here, from the organization perspective, everything is owned by organization. But when you move to cloud, which is these guys, you can share the responsibility with cloud or with the cloud provider, right? At a bare minimum, cloud provider will own the basic hardware and the networking behind that hardware, right? So networking, storage, servers, and virtualization is all taken care of by the cloud provider. What you can do is when you use a cloud services, you can say, hey, just give me virtual machines. I will install my OS. I will patch it. I will take care of it. I will install my middleware, runtime, data, and applications. So you see, it almost takes away the complete responsibility of the IT team. The developers can directly get the machines and manage them. The developers can also say, well, I don't want to manage the operating system and the middleware, right? Why should I spend more time here? Why can't I just develop my application, deploy the application, and then use the data or store the data and I will manage the data. I don't want to worry about all those things. So you can do that. You can hand over all these responsibilities to the cloud provider, right? Or you can say that, I'm just responsible for, my workflows, but not for the application and the data, right? For example, Google Docs, right? Google Docs or Google Drive or whatever cloud storage solution you use, you don't own any of the infrastructure part. You just upload your data and imagine it to be done, right? So you can offload everything to the cloud provider. So these are various shared responsibility models. You share the responsibility with the cloud provider to a certain extent, depending on how much you want to pay the cloud provider. If you use infrastructure as service, like you want to get the virtual machines and you will manage OS and above, then you rely less on the cloud provider. So it is a bit cheaper. But if you want to use platform as a service, you want to offload everything to the cloud provider except your application and data, then you end up paying a bit more because the cloud team is taking care of things for you. And if you want to just use these and not own any of the responsibility for any of the components, then you end up paying more, but you have less headache, right? So an organization also always have to justify what kind of shared responsibility model they want to they want to employ with their engagement with the cloud service provider. Okay, so that's what shared responsibility is about. Right. Another is consumption model. Right. So there are two models for that. Maybe let's see if I can find some diagram, interesting diagram, which we can use. Da, da, da. Yeah, maybe I'll just use this to explain. Right. So consumption model, right? Let's say this or the rightmost column is when you own the infrastructure, right? So your self-hosted data center. If you want to, let's say there is a team that gets newly formed and they want to develop some software and they want computers and storage and things like that, right? So when that happens, what does the company need to spend to get the team those resources? So they first need to have capex, right? That means they need to invest in getting the servers. To set up some sort of data center, they need to construct a room or a building, ensure power is there, ensure all the security measurements are there. Then they set up the servers and they manage the servers and they hire a team to maintain them, right? So that's all capex, which is called capital expense or expenditure, right? Capex. Then the company gets full control of the resources. The company can, predict the performance of the resources because they own the infrastructure. And yeah, this is how it is done, right? So the operational expense, which is day-to-day expense, is very less for a traditional self-hosted database, sorry, self-hosted data center, but it is extremely high for a self-hosted data center, right? Because a lot of investment, initial investment, but running it is low cost. But again, in operational expense, you always have to keep an eye on, server upgrades or technical upgrades, and you have to hire manpower. So those are all operational expenses, right? When you use public cloud, you have no capital expense. If you want one virtual machine, you can get it immediately, right? So one virtual machine you can get. You can meter it by capacity. So if you take a smaller virtual machine, you just pay for that, right? If you want a GPU in a virtual machine, you have to pay for that. You don't have to pay for the entire infrastructure, right? So it is metered by capacity. There's a challenge or there's a high cost involved for egress charges. That means any data going out of the cloud provider will be charged. But that's not the case in self-hosted data center. Egress egress, ingress is not charged at all, right? Then capital upgrades, yeah, you have to buy well ahead of demands for traditional data centers, but it is on the fly, so you can just get new infrastructure whenever you want. You get less control over the resources, where the resources are placed. You can programmatically define those, but it's quite less, right? But at the end, this public cloud comes out to be cheaper, right? And also very, very efficient in terms of manpower and things like that. right? So it is always cheaper, but you get less control on the public cloud. So this is what the consumption-based model is for cloud, right? These are two very important interview questions, right? If you are at the starting level of your career and you want to get into the cloud um, domain, it is there, right? So these are two models of how cloud works. Then there is something else that you need to know about what cloud provides you, right? So it provides you high availability, right? And scalability. That means whatever happens for almost all the time, you can be sure that your virtual machine or your data will be available to you when you use a cloud provider, right? So let's say you go to AWS and then you create a virtual machine, right? Or you go to Azure and you create a database. You should be sure that this database will be available all the time, and there should not be anything being lost or anything crashing, right? And then there is scalability. If you create a VM on AWS or a database on Azure, you can scale it up, right? For example, you can say, hey, I started with one VM, but now I want five VMs. And we started with 1 TB of databases, but now I want 10 TB storage in my database. You can quickly scale it up when you're using a cloud service provider, right? On demand. So you get high availability and scalability, right? You also get reliability. What is the reliability? Reliability is, so high availability and reliability are two terms which sometimes are used interchangeably, but they are not the same. High availability is something is available to you. Reliability is something is working as expected, right? Um, think of it as, what example can I give? Let's say, let's say a very small restaurant, right? A small restaurant somebody has opened in their house. Let's say there's a home kitchen. There's a there's a person who makes good food in their house and they sell it out, right? So can you rely on their service? And is their service highly available? So if you call up the person and say, hey, I want like lunch for myself, can you rely on that? You can't rely on that service because they are running a household and it's something on the side that they are doing, and they may not have all the equipment and the infrastructure to ensure that whatever you want, you will get whenever you want, right? So the reliability of that the availability of the service is very less. Reliability may be high, right? But in that case, reliability is also less. But if you go to Domino's, let's say, and you say, hey, I want pizza, 100% of time you will get your pizza according to the specifications that you will provide, right? So that is a reliable service, right? Uh, Another example is, let's say you buy clothes, right? Many people buy clothes from the brand that they know, right? Levi's or Puma or whatever. Why? Because they are reliable. You can rely on their quality or the functionality that they provide. But if you buy something from a local shop, the reliability is almost zero, right? It's your luck. So from cloud perspective also, you have nice reliability of all the services. You will know that if you have paid for a GPU in a VM, then you will get a GPU with a VM with a specified network speed, data speed, and things like that, right? And same goes with reliability or predictability. You can almost all the time predict how the infrastructure is going to work, right? You can also implement let's say different color. Yeah. You can also implement policies for both security and governance, right? So you can define how somebody is able to access my infrastructure, like, authentication or authorization, right? You can almost define that. You can also define the governance, like policies, like compliance, audits, things like that. So you can implement all these things in the cloud provided infrastructure, right? And a very important benefit that cloud provides is the manageability. You can manage a cloud infrastructure with a lot of ease because it's all using software, right? You can write your Terraform uh, manifests or modules to manage your infrastructure. You can run CLI commands. You can write Python or Java programs to manage your infrastructure. So it's very, very easy to manage, right? So a cloud setup provides you all these benefits. Does that make sense? Any questions on this? Okay, if there are any questions, please send them on the QA window and I'll try to answer them. Now let's talk about Azure. So Azure is one of the multiple cloud providers available. We have AWS, we have Azure, we have GCP. These are the three main players, and they are always fighting with each other um, to gain the market share, right? AWS is the leader, market leader. Azure is almost there along with AWS. Google Cloud is a bit behind, but nonetheless, they are extremely good cloud providers also. Okay, Azure. Azure is provided by Microsoft, right? And it's a cloud service provider. It provides all the shared responsibility model. So it provides infrastructure as a service. It provides platform as a service, or I would say platform as a service, provides software as a service, right? So it provides all these consumption models. Example of infrastructure as service is VM, right? Your storage, etc. So these are infrastructure as service. You own the operating system and above. Platform as a service is like Kubernetes, right? Functions, or you can say application servers like Elastic Beanstalk in AWS. Software as a service is, very, very use case specific. So we'll not talk about that, but it does provide you, software-based storage and things like that. Okay. So any of these individual services that we use in Azure, these are called services. So Azure has multiple services that it provides. It provides virtual machines, it provides storage, multiple kinds of storages, right? It provides Kubernetes, it provides functions, app servers, and many other things, right? These are called services. Now, these services actually run in an infrastructure, right? They own data centers. It's not like they're running it uh, out of thin air. They own data centers. So let's find an image, right? Yeah. So you see here, this is the landscape of where Azure is running its services, right? So these are called regions. All the blue circles are regions, right? So you can see here in India, there are two regions, three regions actually, West India, Central India, South India. Maybe I'll use a different pen color. So we have West India, Central India, South India, right? Then we have South Africa North, South Africa West. We have Australia East, Central, Central to West, and many regions you see here. So what are the regions? The regions are nothing but some big locations where Azure sets up its data centers to provide cloud services, right? So Azure's thinking or any cloud provider's thinking is if the developers are sitting in this part of the world, why should they access Azure services from Europe, right? Or from Australia or from US, right? So to avoid that, what they do is they say, hey, we will set up some sort of locations, data centers, which is very near to our end users, right? So that's why they set up the infrastructure here. Now, regions are the areas where they set up the data center, but each region can have more than one data center, right? So, for example, if we talk about, let's say, West India, right? So let's say there is West India region, right? In West India region, although it covers like a big geographical area, they will have, multiple data centers. Maybe one could be in Mumbai, one could be in Pune, and one could be in maybe Gujarat, right? I'm just making a guess, right? So there could be multiple data center one, data center two, data center three. So these data centers are the actual data centers where they have servers and the complete infrastructure. And these actually are called availability zones, right? Availability zone, availability zone, availability zone. So these data centers actually availability, they are called availability zone and they provide redundancy, right? So if you create virtual machines and then virtual machine crash or something like that, uh, Azure can re-kick the virtual machine in some other zone, right? So this is to provide redundancy of infrastructure for your customers. So there are multiple region, multiple availability zones, multiple availability zones in a region. So one region, multiple availability zones, right? So that's how the data structure or the data storage is created. The regions are actually, there is something called as a region pair. So Azure sets up, identifies two regions close to each other and calls them a region pair. And they achieve it by connecting the databases with a dedicated backbone link. And what happens is you can replicate data between these two regions. So if let's say you create a database in West India, you can replicate the data to Central India as well. So if West India, for example, becomes unreachable for some reason, maybe there is a natural disaster or something like that, it becomes unreachable, then the data is still replicated to the Central India and it's available here, right? So that is how you preserve your data by creating redundancy and data duplication. So region pairs. right? Now, let's talk about resources, the actual resources. So if I open Azure, let's say Azure, just search for Azure, it opens the Azure portal, right? And you can see if I go to products and if I go to compute, for example, you can see there's a virtual machine service, right? So virtual machine is what? It's like a virtual machine, right? Big server, small virtual machines created on them, and you have CPUs and RAMs allocated to those, right? You can define a scale of virtual machine, like how many CPUs, how much RAM, how much storage, which operating system you want, and then you can configure those accordingly. So this is one of the product or service, right? Then you can see there is let's say Cosmos DB, no SQL database, or Azure SQL database, right? Or Kubernetes service. So these are called products or services. So these are all Azure products or Azure services. Let's say you want to set up let's say you want to set up something, right? Let's say you want to um, you have an application and you want to run that application, right? And to run that application, you want to have a database and a virtual machine. And in the virtual machine, there is the application. Let's say it's a Java application. And the virtual machine talks to the database, right? And this virtual machine also has some data disk attached to it. Right? So you have a database and you have a virtual machine, and then you have the disk attached to the virtual machine. Right? Now, how will you get that in Azure? So you will log into Azure, and then you are going to create a VM, you're going to create a DB, and you're going to create a disk and bring it all together. How you do it is not being talked about right now, but this is what you're going to do. Now, let's say this is app for team A. There is another team which is creating app called B. They also have VM and then database and then disk, right? Maybe they have multiple VMs and associated disk, and they all talk to the same database, right? So a multi-tier application, right? This is a single tier application. This is multi-tier application, or they have much complicated infrastructure. So any team can go and create the resources, but how will you identify which VMs are for which machines? If an administrator logs into Azure portal, they will say, hey, I see 5 VMs and 5 disks and 4 databases. How are they related to each other? Which belongs to whom? So in Azure, whenever you create a resource, you have to create resource within a resource group. Okay, a resource is created within the resource group, and it is up to you how do you define resource group. You can say, well, each application will have their own resource group, or you can say each team will have their own resource group, and all the applications go into that single resource group, or however you want, whatever logic you want. But you can create resource groups and then create all your resources within those resource groups. So let's say this is a resource group A, and this becomes resource group B, right? Two resource groups. So this is how you get resource groups. But then you can also create a relationship between resource groups, right? You can also create relationship between resource groups. And how do you do that? You do that by creating yeah, you do that by creating a subscription. So you create it by using a subscription. So let's say you create a subscription A, right? A subscription consists of multiple resource groups. So you can say this big organization has a subscription, and in that subscription, they can create their own resource groups, right? So sales team gets a subscription, and in that subscription, they can create their team-wise resource groups and create resources there. Similarly, other team can create another subscription, right? Subscription B. Let's say the R&D team gets a subscription B, and they create the resources there. So resource groups and then resources inside are created. Just 1 second. Yeah, all right. So you can create multiple subscriptions like this, right? And in the subscription, at the subscription level, you can perform. Okay, for some reason I can't undo this line. So please ignore this line. So you can perform various operations. So you can define the budget of each subscription. You can define policies for each subscription, and you define a lot of governance um, um, and restrictions that you want to put on a subscription. So you can do that, right? Similarly, you can define the budget and policy all here. But then there is one more level. You can actually create a bigger box like this, right? You can create a bigger box, and that bigger box is called management group, right? So what is the management group? Management group could be your company. Let's say I work for Infosys. So management group will be for Infosys. And in Infosys, there could be a subscription for sales team. There could be a subscription for R&D team. And within the subscription, there is a defined budget, there are defined policies, and then you can create your resources. So resource group A, resource group B, and in that you create your own resources, right? So this is how you structure your cloud resources and cloud infrastructure in Azure, right? I think it will be a good idea to some other time or sometime demonstrate the how do we create resources, how do we create resource groups and fit resources in those, and talk about some limitations of those so that we can think about, right? But yeah, so this is something which I wanted to share with you today. This was supposed to, no, this session is supposed to help the 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 beginners in the cloud domain to understand what is cloud, what are the various aspects of the cloud, and what are the benefits and use cases of the cloud, and in terms of Azure, how it all works together. Right. So this is I wanted to share. I can take some questions for like five minutes, and then we can wrap up the session. So keep the questions coming. I do see some questions already. What is a private cloud and what is the difference? So a private cloud is a cloud which is created within your own data center, right? So you set up your own data center and create a private cloud. The advantage of doing that is your developers can, get immediate access to virtual machines. They can order virtual machines like you order on AWS. But again, it is limited with the infrastructure that your company puts in. Okay. A hybrid cloud is a cloud where you use uh, both private and public. So sensitive data you want to keep within your data center, but less sensitive data you want to put it on cloud, or customer facing applications you put on public cloud. So that makes it hybrid cloud. What is the difference between scalability and elasticity? It's almost the same, right? Elasticity and scalability is, most of the times elasticity uh, talks about, well, hold on a second. Let me also look for an official definition. So scalability is long-term strategy ensuring your tech growth. Yeah. So scalability is like a property, right? When you set up your infrastructure, you have to say that my infrastructure should be scalable, right? Elasticity is for a particular instance, right? Oh, hey, are these are the VMs provided by Azure elastic? That means can they scale on demand? So elasticity results in scalability. Okay, you can think of it in that way. Can resource communicate with each other within the same resource group outside? Yes, the resources can talk to each other outside of resource groups also. Please recommend resource for preparing AZ900 certification. Um, it's pretty easy. AZ900 is pretty easy. You can, yeah, you can just look for this guy, John Savin, and just go through his training. I think he covers everything. Question: how to switch Cloud 1 to Cloud 2? Can you just give me a second? I'm getting a call. Sorry about that. So switching between Cloud 1 and Cloud 2, that's a really challenging work, and it's actually a project, not even a task. So you really have to define the strategy, how you want to, organize your resources. Different cloud providers work differently. For example, in Azure, there are resource groups, which are pretty nice. In AWS, there are no resource groups. So the resources are just lying around freely. So you have to define, there is no single strategy that can answer a question. But yeah, can't answer more than that. If I want to set up simple Azure app using its different kind of resources, then which certificate should I go for? Just go for Azure Developer or Azure Administrator. So either AZ104 or AZ400, I guess. So AZ104 is something that you should take for your, normal Azure, yeah, your normal Azure thing. Azure developer, you can take Azure developer or DevOps engineer for that. I think let's take a look at Azure developer. If you just want to deploy your services, Azure developer is fine. So I think it's AZ204. Yeah. So this should be okay, right? You can see uh, storage options, SDK options, compute options, and things like that. And yeah, so should be enough. But I suggest for just for starting, go with AZ104 for everyone. How best the availability in Azure works for the distributed database model, say around 800 databases. So if you have to create databases and distribute them, there are a lot of challenges um, when you deal with databases. It requires a lot of data integrity and data consistency and things like that. So if you manage databases on your own, that becomes a big problem. But if you use their database product like Azure SQL and all, then you can have a much more reliable solution. You can distribute the databases, you can replicate the databases. So yeah, that's all possible. Yes, this recording will be available for you. Okay, so thank you for the questions. Thank you for your time. And this recording will be available for you. Okay, there's a question which I missed. Please elaborate why cloud came in the market. So I did explain it in detail when we talked about, why do we need cloud? So I think that pretty much covered it. Thank you so much for your time, guys. And please refer to the video again. If you're preparing for Azure, there are more webinars that we do. Skill Applied and me, we do together. So hopefully I'll see you in the next one. Right. Thank you and have a good day. Bye.